Good afternoon. I will talk about changing pathology in an aging society. Next slide. The world is facing an unprecedented situation. There are now more older people than children and more people at extreme old age than ever before. At present, the number of 65 years older people outnumber children younger than 5 years worldwide. Aging will continue and accelerate, and the United Nations World Population Prospects from 2010 project that there will be an increase of 500 million 65 and older people worldwide to 1.5 billion people in 2050, and this mostly in developing countries. In the early 20th century, major health threats were infectious and parasitic diseases, and they claimed lives of children and infants. Nowadays, the non-communicable diseases affect adults and elderly people, and these will impose the greatest burden on global health. Next slide. This graph illustrates the increasing number of 65 years and older people and the decrease of children younger than 5 years worldwide as projected through to 2050. Next slide. An illustration of the percent of change in the world's population by age projected again to 2050 says that there is an increase of 22% of people younger than 65, whereas the older than 65 will increase with 188%, and the older age groups, 85 and older, will increase with 351%, and even the centennials will increase with over 1,000%. Next slide. The increasing burden of chronic non-communicable diseases as projected by WHO for 2030 is that especially in middle and low income countries, there will be an enormous increase from non-communicable diseases. Next slide. Key questions are, will population aging be accompanied by a longer period of good health, a sustained sense of well-being, and extended periods of social engagement and productivity? Or will the aging be associated with more illnesses, disabilities, and dependencies? Anyway, aging will affect healthcare and social costs, and this worldwide. Next slide. Here you have a graph of people older than 65 years in Europe at present. And you see that in countries like Germany and Italy, already over 20% of the population is older than 65 years. And other countries like Greece, Austria, and Sweden are approaching 20% of 65 plus people nowadays. Next slide. The burden is to understand and find cures to prevent diseases like Alzheimer's and frailty, two diseases which are typical of older age persons. It's also a burden to extend existing knowledge about the prevention and treatment of heart disease, stroke, diabetes, and cancer. The improvement of life expectancy, however, is accompanied by the rise in chronic non-communicable diseases such as heart disease, diabetes, and cancer. And they reflect changes in lifestyle and diet and aging. The economical and societal costs of non-communicable diseases of this type rise sharply with age. And they can affect economic growth. Next slide. Another burden is that the non-communicable diseases will increase enormously in low and middle income countries. And the WHO estimated that the cost of 3 diseases like heart disease, stroke, and diabetes are about $83 billion between 2006 and 2015. Reducing severe disability from disease is one key to holding down health and social costs. However, active and healthy old age is hampered by the rising incidence of dementia, Alzheimer's disease. And it is estimated that at present, 25 to 30% of people older than 85 years have dementia. Next slide. Here you see a graph estimating the increase of dementia, Alzheimer's disease in especially low and middle income countries and less so in high income countries. Next slide. Aging is an important risk factor for most chronic diseases, and it may be considered to be the result from the accumulation of cellular damage, consequent changes in gene expression, and epigenetic factors related to DNA damage, and structural modifications of DNA, such as telomere shortening. Telomeres have TTA GGG repeats at the end of the chromosomes, and by each cell division, they lose these ends so that the chromosomes cannot replicate anymore when the TTA GGG is consumed. And aging is considered to be an interaction of genetic and environmental factors. And two main theories are the free radical theory and the replicative senescence theory. Next slide. The free radical theory states that an increase of radical oxygen species is generated by exogenous processes like irradiation, environmental pollutants and inflammation, and also by normal cell metabolism. Radical oxygen species can accelerate replicative senescence by shortening of telomeres. Active inflammatory redox sensitive transcription factors like NF-kappa B that regulate transcription of genes encoding pro-inflammatory cytokines and induce DNA damage. Chronic inflammation, which is characterized by higher levels of pro-inflammatory cytokines and infiltration of inflammatory cells into tissues, is a feature of aging, and most age-related diseases, including chronic obstructive pulmonary disease, cardiovascular disease, osteoporosis, rheumatoid arthritis, cataract, and dementia, are accompanied by this inflammation. Next slide. The other theory of aging is the replicative senescence theory, based on the fact that with every cell division, there is incomplete duplication of the telomeres at the ends of chromosomes and containing TTA GGG repeats that protect the DNA against degradation and recombination, thus supporting chromosomal stability. In most somatic cells, telomeres shorten with every cell cycle, since replicative DNA polymerases lack the capacity to completely replicate with every cell cycle with the terminal ends of linear DNA molecules, which is a property of specialized DNA polymerase known as telomerase. Most mammalian somatic cells do not express telomerase. And this leads to loss of telomere protective sequences at the ends of chromosomes. This is a result of the replication history, but also of a number of factors like cumulative oxidative stress and chronic inflammation acting on progenitor cells. Successive cell divisions result in telomere shortening of chromosomes until cells are no longer capable of dividing. Therefore, the balance between cell death and cell replication is affected, and defense, maintenance, and repair of the body becomes increasingly impaired. Telomere length is considered as a measure of biological rather than chronological age, or as a biomarker of somatic redundancy, that is the body's capacity to absorb damage. There is a strong relationship between short telomeres and the risk of mortality. Next slide. In conclusion, understanding the mechanisms of aging may provide a novel target for the treatment of aging. And understanding the mechanisms of aging will also help to prevent and treat communicable diseases. Thank you for your attention.